Well, good morning, math analysis. I'm at Allstate Speech today with Brooke and also with the seniors who are at Allstate. And since a lot of you were gone last week, we're going to try to go through a PowerPoint and actually have you learn some stuff today. You should remember that back before the Nashville trip, we were talking about arithmetic sequences. And the whole idea of an arithmetic sequence is that you kept adding or sometimes subtracting the same number over and over again. Here we have a sequence where you're adding two boxes each time. So 1, 3, 5, 7, 9, the next one would be 11. We also learned earlier what we called the general term or the formula for an arithmetic sequence, which looked like an equals a1 plus d times n minus 1. In order to find any term of the sequence, you take the first term and you add whatever the common difference is, one less than the number of the term that you're on. Well, today we're going to expand a little bit beyond arithmetic sequences. And to do that, we're going to start by looking at four questions that we're eventually going to figure out how to find the answers to. So the first question says, if you added all the numbers from 1 to 10, what would the sum be? You can think through that and probably even come up with an answer in your head, but we're going to take it further. We could ask, for instance, what would you get if you added up the 36 numbers on a roulette wheel? Or you could ask, what if you added up all the numbers from 1 to 1,000,000? Or even all the numbers from 1 to 100 trillion? These are all kind of the same question, just going higher and higher and higher. And a slightly more complicated question, what if you added up the multiples of 3 from 39 to 150? What all of these have in common is that they involve adding up sequences. And in math, the term we use for that is a series. A series is just the sum of the terms in a sequence. So you take a sequence and you add up all the terms. There's a lot of ways that you can write out series, but one of the most common involves using the symbol that is the Greek letter sigma. Sigma looks kind of like a pointy E. It's actually where we got our letter S from. And if you see that symbol, what it means is add up or sum. So here's an example of how we would use the sigma notation. You'll notice that there's that sigma symbol. On the bottom, it says n equals 1, and on the top, 6. And then after the sigma, it has a formula, which in this case says 4n. So what that's telling you is you're going to add up terms that you get by plugging in the numbers 1, 2, 3, 4, 5, and 6 into the formula 4n. So I take 4 times 1, I get 4, 4 times 2 is 8, 4 times 3 is 12, and so forth. Basically, it's saying I need to add up the first 6 multiples of 4. 4 plus 8 plus 12 plus 16 plus 20 plus 24. And here's a different example, but the same basic thing. The n equals 1 at the bottom and 6 at the top are telling you that we're going to add up 6 different numbers. And I get those numbers by plugging in 1, 2, 3, 4, 5, and 6 into the formula 6n plus 2. So 6 times 1 plus 2 will be 8. 6 times 2 plus 2 is 14, and so forth. You add up 8 plus 14 plus 20 plus 26 plus 32 plus 38. So here you have a symbol. We have a 3 at the bottom, a 7 at the top, and then 5n plus 10. I want you to pause the video for a second and think, what would this mean that you have to add up? This is slightly different than the other examples because here the first number we plug in is 3. 3 times 5 is 15, plus 10 more gives me 25. So the first thing we're going to add is 25. Then I plug in 4, 5, 6, and 7, and we end up adding up 25 plus 30 plus 35 plus 40 plus 45. You'll see some problems where they give you some numbers and they ask you to write this in sigma notation. There's often many ways that you could do this, but the easiest is to start with the sigma symbol, think of how many numbers we're adding up, and then what would be a formula you could use to get those numbers. Here we're adding up 5 different numbers, so that's why at the bottom I have 1 and at the top I have 5. And these happen to be multiples of 5, so that's why the formula here is 5k. Now you can actually use any variable you want. Most of the time in formulas for series, they'll use either I, J, or K just because those letters are often used as counters. But it can be literally any variable, and it means the same thing. Now remember that all the examples I had earlier involved adding up different amounts of numbers. Like, what do you get if you add up all the numbers from 1 to 10? Well, it turns out there's a really easy way to answer those questions, and that's what we're going to talk about finding out next. Now, the formula that we use to find the sum of an arithmetic series looks kind of complicated, but what you do actually isn't all that hard. You'll notice at the left it says I equals 1 and n, and we got that sigma symbol. That just means we're adding up n terms, some number of terms. And on the right, we have n over 2, a1 plus an. The n over 2 just means we take the number of terms divided by 2. So if there's 6 terms, you'd take 6 divided by 2, that's going to be 3. If I had 10 terms, I'd have 5 there. It's just always the number of terms over 2. And then in the parentheses, it says a1 plus an. That just means the first term plus the last term. So n over 2, first term plus last term. And that's exactly how we do the problems that we had for the examples earlier. Here it says I want to add up all the numbers from 1 to 10. Well, that's 10 numbers. So the first thing I'm going to do is take 10 over 2, which is 5. First term is 1, and the last term is 10. And that's why what we want to do is take 5, 10 over 2, times 1 plus 10, or 5 times 11, which is 55. Again, it's just number of terms divided by 2, and then in parentheses, first term plus last term. So the next question is, what would happen if you added up the 36 numbers on a roulette wheel? You might want to take a minute, maybe pause the video and see if you can figure that one out. And all we do is take 36 divided by 2 times 1 plus 36. And we do get an answer of 666, which is why sometimes they do call this the devil's wheel. And the next two questions were basically the same thing, but with different numbers. What if you added up all the numbers from 1 to 1,000,000? And how about 1 to 100 trillion? Well, you're going to do basically the same thing, but you have different numbers of things we're adding up. So the idea is still the same. Here I did 1,000,000 divided by 2 times 1 plus 1,000,000. And you can see we get 500,500,000 as our final answer. And when we do the 100 trillion one, we get a ridiculously large answer. It ends up being about 5 octillion, but the idea is still just the number of things divided by 2, and then first number plus last number. The other question I had back at the beginning is, what if you added up the multiples of 3 from 39 to 150? This is just a little bit more complicated because it doesn't count by ones and it doesn't start with ones, but the basic rule is still exactly the same. I put on the screen here exactly what you would be adding up. It's like 39 plus 42 plus 45, and you keep adding an extra 3 each time until you get to 144 plus 147 plus 150. If you look through this, it turns out there are 38 things we're adding up. So I take 38 divided by 2. First number is 39, the last number is 150. We add those up and you can see the overall answer is 3,591. And so again, the big thing you want to remember is you always take the number of terms divided by 2, and then in parentheses, first term plus last term. That gives you the sum of any arithmetic series.